So thank you for coming today. Welcome to our MCB specific workshop for the LAS Student Success Workshops. This workshop is mainly about succeeding in the MCB Core Courses, but it could also apply to some of your other biology classes as well. Just show of hands, how many of you guys are in an MCB class right now this semester? Almost everybody. Okay, raise your hand if you're in MCB 150. 250? 252? 354? Okay, cool. Alright, so my name is Alejandra Stenger. I'm a life science teaching specialist in the School of MCB. I'm the course coordinator for MCB 354, which is our majors biochemistry lecture, and I'm also the merit director for MCB. My contact information is listed here. I'm in the main office in 252 Davenport, the MCB Core Curriculum office. And just a little background about the course coordinator. So I know that you guys meet with your advisor, hopefully, your academic advisors in MCB, but there's a whole other resource of people available to you, and that's the course coordinators. So for all of your courses, for MCB 150 through 354, there's a coordinator. And that person is responsible for a lot of the administrative aspects of the course, but we're all biologists. And we work with the professors and faculty to develop the course materials. We oversee the teaching assistants and all the training, and in addition to things like administering your exams, we have a lot to do with what we do in our discussion sections and in our lab sections as well. And so if you have questions about a course, it's a good idea to come talk to your course coordinator in addition to your academic advisor, because your course coordinator knows the specifics for that course, can talk to you a lot about tips and strategies for doing well in the class, talk to you about how you're doing, your grade, and study skills and things like that. So if you haven't already gone to your course coordinator at some point, we really encourage you to do that. We're available to you as well. So with the academic advisors, the course coordinators all together, we're all the instructional program at MCB. And even if you're not in 354, if you want to come and talk to me later or send me an email or get a hold of me, please do. All right, so for today's workshop, we're going to go over a few different things. So one, we're going to talk about critical thinking and how it relates to mostly to your exams, but we're going to talk a little bit about that. We're going to talk about reading and note-taking in general, and then more specifically in science courses. We're going to talk about how you should approach exams in your science courses. We'll talk a little bit about learning styles, and then we'll do a brief review of time management, because hopefully that's something that you guys are already thinking about. So, you don't have to write it down, but in your head, think of two things that you think are things you could do to be successful in your biology courses. It could be things that you're currently doing, or things that you think you should be doing but aren't, or things that maybe you've seen some of your classmates do that do really well in their biology classes. What are some ideas for things you can do to do well in MCB? What do you think? Anybody?
Office hours?
Office hours, right? Yep, professors' office hours, TA's office hours. There's lots of available times to go and ask questions and to talk about the material. What about something else?
Yeah. Reviewing your notes the same day after classes?
Right, reviewing your notes. So going to class, taking your notes, reviewing those notes after lectures, after class, going through and double checking to make sure you didn't miss anything, making sure you can answer questions about that day's material. Anyone else want to volunteer anything else? So there's all kinds of things, and we'll talk about some of those today, and hopefully by the end of the session you can think about some things that you can incorporate into your own studying that you might not already be doing, or things that you might be able to do a little bit differently. Okay, so we're going to switch gears for a second. Think about a penny and the front of a penny and what it looks like. So everyone's seen pennies, right? I know people don't carry change as much as they used to, but everyone has seen a penny, right? You all know what a penny looks like. So what are some characteristics of the penny? Who's on the penny? Let's start with that. That's the easy one, right? Lincoln, right? Okay. Is Lincoln facing right or facing left on the penny? Left? Does everyone agree? Yeah. Convinced? What else is on the penny besides just Lincoln's face? On the front?
Oh, no.
Words, right? Some writing on the penny. Does anyone know what the words are? I know that's a tricky one. What else is on there besides words and the face? The year, right? And is the year on the right side of Lincoln or the left side of Lincoln? Not sure, right? What about the writing? Is the writing on the top or the bottom? The face. Top? Okay. What if you saw a lineup of pennies? And I know these aren't super clear to look at, but some are facing right, some are facing left. We've got words on the top, we've got years on the left, years on the right. Some of them have some additional writing on them. Which one of these looks like the correct penny to you? E? E or A? Anyone have a vote for a different one? Alright. So we've seen pennies a lot, right? We've been exposed to pennies a lot, and even when we start to think about them and try to figure out what they look like, it's really hard to do that. And this is similar to what happens to students. You might be in a class where you're talking about content that should be familiar to you, or you think it's familiar to you, so maybe you don't study that as much. Maybe you skip over that, you don't spend a lot of time on that. Maybe you're pretty sure you know it, and then you get to the exam and you get asked all these questions about it, and you realize maybe you don't know that as well as you thought you did, right? So this is just a very quick visual example of how something like that can happen. And in MCB, you guys know that your exam questions are pretty detailed and pretty specific, and a lot of times they're not exactly the things that you studied, right? Sometimes they're more application-based, more critical thinking-based. So we're going to talk about some things today that can help you with that. Okay, so the first thing I want to talk about is the concept of scientific teaching. So like I said, all the course coordinators are scientists, we're all biologists. We all have a background in that, and we all have focused our work essentially on science education and science teaching. And so we approach teaching like we do science. So what we do is we establish goals and outcomes for what we want students to be able to do. And so this is something that we want students to be able to do, and it can be for a lesson, it can be for an assignment, it can be for a unit of material, it can be for an entire semester, and it can go across courses for the entire curriculum. And so this is how we decide what we're going to cover in our courses and how we're going to test you guys. We then develop assessment and evaluation. So this is your assignments, your quizzes, your exams. These are the questions that we ask to see if you guys have understood and learned your goals and outcomes that we've set forth for either the lesson or for the course. Then we also develop activities, and so you'll have discussion activities in your discussion sections, and your lab courses, it's all activities. And then we look at alignment. So what that means is we go back and we look to see if the activities and the assignments that we planned go back to our goals and outcomes and really measure what we're trying to teach you guys. And then part of that is also including collaboration and diversity. So you'll do a lot of group work in your classes. In labs, you'll have a lab partner. We try to cover things in different ways for different learning styles. And all together, this is kind of how we approach what we're going to do in our courses at MCB. How many of you guys have heard of Bloom's Taxonomy? Okay, good, all right, great. So if you haven't, this is pretty much what it is. So we talk about it like a knowledge dimension, and there's different levels. And so we have factual, conceptual, procedural, and metacognitive. And so these are different ways in which we develop our questions and our assessment for the courses. And basically factual is just the basics, right? So terminology, definitions, the elements, the details of just the basics. You're gonna see in your classes, and you already probably have, that we don't usually ask a lot of questions like this, right? We don't ask you guys to memorize terms straight out of the book and test you on that. We are usually going somewhere around here. So concepts, procedures especially in things like your lab courses. And so we're really trying to push you guys. We're pushing you to be scientists, to be doctors, and we want you to think about the material at a more advanced level. Not to say that you don't need to do some memorizing. There's obviously some facts and some things that you just need to know to be able to get to those higher levels. But that's why a lot of times you're not going to see questions like that. Your questions are going to be more complicated. And so this is another way to look at this. So if we look at the levels going from lowest to highest, we've got things like remember, and so that's the basic. Can you identify it? Do you remember it? Understand. Can you put those things together? Can you compare them, contrast them, explain what they are? Apply. Can you put those things together and implement something or make something? Analyze. Can you tell the difference between things and make decisions based on that? Evaluate goes along with that. So having a judgment about something, being able to test something. And then finally create, which is the highest level, designing or constructing your own thing. So this is a lot of what we do in our lab courses. So let's look at these a little bit more specifically with an example. So one example we're going to talk about is graphing, the skill of graphing. So we throw that in to a lot of courses in different ways. And let's just think about different ways in which we could ask questions at the different levels. So for knowledge level, we might ask you to identify the parts of a graph. So we might ask you what's being graphed on the x-axis or the y-axis, or what is the scale of the graph, right? So just the very basics of what the graph looks like. We might then ask you to describe the data. So that's another level up. So now you have to say something about that. Is the data trending upwards? Is it decreasing? What is happening on the graph? The next level you'll see is things like application. So we might give you a set of data and then ask you to graph based on the data that we've given. And then based on the data that you've graphed, be able to make a prediction based on that. Another way we can test on graphing is analysis. So we might give you a graph with different variables. Maybe instead of having one line, now there's two lines. And we might ask you to talk about that, what that means. Synthesis is where you might have to create your own graph based on a concept. So we might tell you that something's happening in a biological system, and then you have to sketch out what that graph would look like. And then finally, evaluation. This could be a type of question where you are asked which type of graph might be more useful for that situation or that application. So maybe you might have a line graph or a scatter plot, and you have to decide which might be better to show the data. So that's how you can think about blooms in relation to something like graphing. And then another thing that we can think about is molecular techniques. I didn't put anything really specific on these because I wasn't sure what MCB course you were going to be in. And so this can be things like gel electrophoresis for DNA. It could be a restriction digest. It could be protein purification, a Western blot, things like that. So all of these just kind of go along the same lines. So for knowledge, we might just ask you what is being measured, right? And so in a gel, we might just ask you, what's the experiment? What are we doing? Understand results. In this case, you have to know what it is, but what does it mean, right? So how do you interpret that? Application, we might ask you to draw expected results, predict what technique to use. So in, let's say, a DNA gel question, we might say, okay, if you use 2 restriction digests or 3, how many bands might you see on that gel when you run it? For an analysis level question, we might have something like interpret data from the results. So you might get 3 or 4 pictures of gels, and then you have to figure out what that means. How were those restriction digests cut? Synthesis. You might be asked to design an experiment using techniques. So these are the types of things that you'll see now in MCB 251 lab and MCB 253 labs. So for 251, you usually have an unknown plasmid that you have to work with throughout the semester. For 253, you get an unknown protein. And so we teach you guys the basics, and then you have to design an experiment using those techniques to figure it out. And then evaluation. Why might you use one technique as opposed to another, and how are those going to give you different results? For 253, that's pretty much the whole semester, right? The end of the semester, and the poster presentation, students show the different things that they did to figure out their unknown protein. So they might have done a Western, they might have done some other purifications to test that, and so this is really what we're trying to get you guys to do. We're trying to get you to these levels of blooms when you're analyzing, putting the facts together, and being able to create something and evaluate something and how it works. These are the types of questions that you'll see on our exams as well. Okay, so like I mentioned, we want you to move past memorization. Memorizing in your MCB courses is just not an effective way to study. And hopefully you guys have already seen that. You should study actively. So studying should not be a passive process. You should be taking notes as you read. You should be taking notes in class. You should be asking questions, either to yourself or aloud. Asking questions, there you go. You should consider multiple points of view. Study groups are a great opportunity to talk about the material. Going to office hours, talking to your TA after class, all of these things are going to be important. And then being able to draw conclusions, so understanding how the material fits together and how all the material you've learned builds on each other. And really that's kind of the point of our core curriculum and why those courses are designed in the order in which they're set up. Okay, so reading. We take a lot of time deciding which books we're picking for our courses. And we do that on purpose. And we think about the layout and the way that the material is presented, and these are all things that we think are going to be helpful for you guys as students as well. So survey the reading. Look through the glossary, look through terminology that might be unfamiliar to you and be able to find those resources. Notice anything that is marked in a graph or a box or a chart or a table. There's usually a reason that that's visually different than the rest of the page. And these are usually important concepts that are going to come up in assignments and exam questions. Write down questions as you read. If you aren't sure about something, jot it down, and then you can either go back and review the reading and answer the question yourself, or you might go to your instructor's office hours and ask them as well. Actively read for details. It's really easy to just start skimming pages and not pay attention. So when you're reading, make sure that you really focus on the content. Look over examples and how the content relates. A lot of times you're going to see a worked example, and those are really important because those are the types of questions that you usually see on exams as well. And it might not be the same, but it might be emphasizing a particular concept that we've talked about in class. And then recite answers to questions. So in most of your textbooks, you're going to have questions at the end of a section or questions at the end of a chapter. These are all good ways to check in and make sure that you are following the material. And if you can't answer those questions, go back and reread, and if it's still not clear, go to office hours and ask. And review the reading. So a good thing to do is read the reading before you go to class and then after you go to class, and take notes. Sometimes if you read it before class and you're not sure about something, once you go to lecture, that might make more sense. Sometimes you're still confused, so go back and reread it. If you're still confused, ask questions. And then consider drawing out or mapping out your notes when you're reading. Some students are more visual learners, and sometimes that's helpful. We'll talk a little bit more about notes in a second, but making sure that you're actively reading. So this is another way to kind of force you to pay attention as you're reading the pages and not just skimming through them quickly. So general note taking, one thing I want to say is to take notes in a way that's effective for you. There are lots of different note taking formats, and so some people like writing a list, maybe bullet points. Some people like doing an outline with headings and subheadings. Some people like drawing concept maps, more of a visual representation of the material and how the things fit together. That's totally fine, but figure out something that works best for you. Be able to identify all the main ideas. This is why outlining is a nice way to do that, because you can highlight that way. Don't write everything down. So a lot of times in lectures, students are frantically trying to write everything. You're going to miss some main ideas. So consider recording lectures. A lot of our students record the lectures and then listen to them later. That's a nice way to do that. Also, think about having the PowerPoints or the lecture slides so that you can just annotate them and not write everything from scratch. And keep yourself organized. It's a lot easier when you go back to study if you can figure out what you wrote. If you've got stuff all over the paper or in different notebooks or all over, it makes it way, way harder. Download visuals. So in all of our courses, you should have the lecture notes and the material available ahead of time that you can download. And if there's a figure, an image, or a graph, or a structure, it's a lot easier to just add the little notes to that structure than it is to draw it all yourself. So anything you can do to just jot things down is usually helpful. And then some more specifics for note-taking in science. Write equations, formulas, diagrams, graphs, anything that is specific to that content that you're covering, so that you can make sure that you commit that to memory and understand the process of how that works. This one I think is important, writing down technical terms or things that an instructor says a lot, especially if you're not sure what it means. When you write it, put it in quotes for yourself, then go back and look. There are certain professors that say certain things in a certain way, and usually those are the kinds of things you're going to see on an exam too. So Brad Mertens does this a lot. There are certain little terms that he says a lot. And if you weren't sure what that is, then you get to the exam and then you're gonna wish you had looked it up, right? Write worked examples step by step. So for a lot of the more difficult concepts, you'll see example problems in your text or maybe in class. Make sure that if it's a multiple step problem that you write down the steps as a process. It's helpful to think about it as a thought process, but also you can see where you can go wrong. So if you start off, for example, this happens a lot in MCB 354 in biochem, you might have an equation, a calculation that you have to do. Write the formula, write all of the constants, write all the variables with units, and then do the problem step by step. It's easier to see where you go wrong that way than it is to just skip steps and get to the final answer. Also, it's a good way to make sure that things seem logical. So if your answer is some order of magnitude that doesn't make sense in a biological system, then you can go back and check your work and say, oh, I divided instead of multiplied, or I did the inverse of this, or my sign is wrong for this. So that really helps when you do things in a worked out process. Consider writing your notes, and what I mean by this is physically writing them as opposed to typing them. So there's been lots of studies recently talking about how writing notes is more effective for students. Something about the way that that gets processed, you can retain that information better, and so really consider writing. Also, it's better because you aren't as distracted as you are when you're online. So we know you guys are on all kinds of social media things and shopping and whatever else, and so if you just have your notebook out and you're just taking notes that way, you might be able to focus a little bit better as well. Listen to other students' questions. So sometimes you might not think you have a question, and you might not, but you hear somebody else ask a question, and then you realize, I didn't know that either. And so there's lots of common questions that will come up with the material, and common confusion for certain concepts. So sometimes you might not even realize you don't know something unless you hear somebody else say it. Use symbols and highlights. So any way that you can make your notes effective and efficient, anything that you can do to kind of streamline that. When I write notes, I have different colored pens, I have different colored highlighters, and so those things all combined really help visually to keep me organized. And then refer back to the textbook after class. And so if you've taken your notes, in addition to reviewing the lectures, going back through the reading is usually going to help fill in holes where maybe you missed something. And then I always recommend students keep their old notes for future classes. So one is because all the core courses build on each other. So if there was a concept in MCB 150, you're probably going to see that again, either in 250 or 252 or 354, but in greater detail. So if you get to 250 and you don't really remember something, you can go back and see how it was covered in 150 and then build on that. Another reason it's nice to keep notes for MCB students, I think, is because so many of you guys are pre-med or pre-health or pre-professional, and so all of the things that we cover in our courses usually end up on the MCAT or the GRE, and so if you have kept your notes, that is a nice study guide for you to have. So you're not starting from scratch when you're going through the material. You already have a guide of what you have studied in your other classes. Okay, and attending class. Obviously, attendance is important, right? So hopefully everyone goes to class. But in addition to just going to class, there's some things that you can do to be a little bit more prepared. So prepare yourself for going to class. Do any readings that might be assigned. Any pre-class assignments. In some classes you're going to have pre-lecture or pre-lab quizzes. Read through the syllabus. Make sure you know when things are. It's really easy to miss points or assignments if you don't know when you have a quiz, for example. That happens in 354 every semester. Make use of all the materials that you have available to you. You might have, most of our classes have an e-text or an online textbook. There are tutorials, animations, extra practice questions usually in those resources. Even if they're not assigned to you, that's all information that you have available to you. Lots of students like to look up things on YouTube, different concepts from class, that's fine as well. And get organized. It's up to you to know when things are due, when your exams are, and everything else that's coming up. Participate in class. So you could do this as actively or as passively as you would like, but listen. So listen for the main concepts and central ideas. Decide what's important, ask questions, organize and categorize what's being presented, and really spend your time focusing on lecture. That's why you're there. Okay, preparing for exams. So prepare emotionally, prepare physically. What I mean by this is eat, sleep, rest. In addition to studying and preparing for the content, make sure that you're prepared yourself. So some students will stay up all night and cram for 2 days. That's not going to be an effective way to study for classes in MCB. Make sure you're eating real food. Just having like candy and Red Bull for days and days at a time is not going to be helpful for taking exams. Design an exam plan. And so this can be done ahead of time. Think about your study time. Think about the day of the exam, where you're going to eat, what time you're going to get to the exam room, where your exam is. All of those little things can make a big difference. Consider joining a study group. So in a lot of our courses, we have students that do study groups, and it can be really helpful because one, you get to hear other questions and other perspectives, but really, like we always say, the best way to know if you understand something is if you can teach it to somebody else. And so if you can't explain it to the people in your group, then you know you have to study a little bit harder on that particular concept. Do assignments, homeworks, anything that is available to you to practice, do it regularly, and even if it's not graded. So any additional questions that a professor might give. I know this week there are either practice exams or old exams, depending on the class, that are posted on course websites usually. Look through those. There's no excuse for not looking at those questions. In almost all cases, those are old exam questions, usually from the same professor who's taught it. So if you see similar questions on the exam, that's usually what happens. And a lot of students don't take advantage of those practice or extra questions. Attend class and be on time. So obviously attendance is important, but being there on time can be important because a lot of announcements might get made at the beginning of class periods. Things about the upcoming exam, things that students might need to know. A lot of times we'll talk about like what lectures are going to be covered on the exams, and sometimes if you miss that at the beginning, you might not see that later. And create a study guide. So a lot of students, a lot of courses will give students a study guide. If the instructor doesn't do that, you can make your own study guide. And that can be a combination of your notes that you've written, your notes from your reading, your lecture notes, everything combined, and any practice questions that you might have seen. Keep a list of terms and formulas. So if there are lots of terms, a lot of terminology that's being used in the class for that particular unit, that can be really important. In classes where there's more calculations, like in biochemistry, formulas are going to be important. We might give you a sheet with formulas like we do in biochemistry, but you still need to know how to use them. You still need to know how to solve those equations and get the answer and be able to understand what the answer means as it relates to what's being asked in the question. Read the directions. There are easy little things that students sometimes miss if they don't read the directions carefully and pay attention to those things. Make best use of your time. So for most of our core courses, the exams are 2 hours, which sounds like a lot of time, but you don't want to be wasting time on things where you can get stuck either. Jot down ideas, jot down notes for yourself. A lot of times we'll have students coming into the exam, they have something in their head that they don't want to forget. That's fine, write it down, write it in your booklet. For most of our courses, those booklets are yours to keep and you can take them with you. And so we don't care if you write any extra things down. I had a student last semester that would write herself little motivational notes on the cover sheet. That's fine, I don't care. Whatever you guys want to do that helps you is fine. Go through the booklet, go through it, see how many questions, see how many pages you have. Answer the easy questions first. If there's certain things that you just know and you're not worried about them, get them out of the way. You don't have to answer the questions in order. Take note of any key words. So these are example words when we talked about blooms and the different levels of cognition. So really pay attention to that. If the question says to compare or contrast or analyze or discuss or define, those key words are going to tell you a lot about how that question needs to be answered. Sometimes we have students that might write a correct statement, but it doesn't answer the question. It doesn't address what we're asking. And so these key words are going to really help focus you. And for multiple choice questions, which are most of the questions you'll see in your MCB exams, a nice tip for that is to read the question itself, and before you look at the answer choices, try to predict what you think the answer should be, and then evaluate the answer choices. Hopefully there's a couple that look really good, and you can kind of narrow things down from there. Also note that when we write these multiple choice questions, we know what students' common misconceptions are about the content in the courses. And we've got lots of experience of where students go wrong. So some things are going to look pretty good. We might give you a DNA sequence and we might write it in the 5' and 3' or the 3' and 5'. If there's a calculation, we might multiply something instead of dividing it by a certain number. We might give you the positive value and the negative value. these are all ways that we're trying to get you to, we're trying to see who really knows the material. We're not trying to trick you, we're not trying to be sneaky. But on a multiple choice exam, this is how we can evaluate if students understand those concepts. So pay really close attention to those questions because, again, there are certain answer choices that are going to look really good. And then stay to check your answers. Hopefully you don't run out of time and you can go back and just review things. That said, don't obsess about an answer and change your mind multiple times because sometimes second guessing yourself isn't great either. Sometimes go with your instinct, but double check things like making sure that you answered every bubble on a Scantron. Making sure you didn't skip a line, for example. Making sure you didn't put 2 bubbles on one line. And really important to just go back through your booklet and make sure that whatever you circled or indicated on your booklet is what you have on the answer sheet. I work in the main office, which is where we keep the Scantrons, and every single exam somebody comes to look over their Scantron because they are positive that they bubbled in A but they circled B, and it just happens every time. So just make sure that you check your answers. And then this, I think, is the most important tip on this slide. Review your graded exams. This is something that students do not like to do, especially if they did not do well on that exam. So if you maybe didn't do as well as you had hoped, it's really easy to not pick up your exam or not look at it or throw it in the garbage or just pretend it never happened and move on. That is very tempting, but these exams are your opportunity to learn how to do better, right? So on the one hand, you're going to have another exam by that same professor probably. So things like the style of writing, the types of questions that they ask. If you struggled with that, if you go back and review those, then when you take your next exam, that should help. Another thing to think about, all the material is going to build on itself. If you didn't understand the material from exam 1, exam 2 is going to be even harder. And so review those questions, go through the answer key. If you still don't understand why you got something wrong, go to the professor, go to your TA, ask somebody, go to your course coordinator. We keep a list of, for every question, what content that covered, what level of blooms that was. We can talk to you about those things. We can talk to you about how to approach those questions maybe in a different way. So make sure that you do review those exams. Okay, and then just very briefly on learning styles. So I'm sure everyone is aware that everyone learns differently. These are the 4 main types: visual, oral, read, write, and kinesthetic. And so certain things might work for certain people, and what I just want to emphasize here with this is to do what would work best for you. That might not be what works best for your friend or your roommate, and if you're not getting the results that you want doing that, try something different. So for some people, it's really helpful for visual people to draw sketches, to do concept maps to show how things are related. For other people, they like to record the notes and then listen to them. Other students like to read and rewrite their notes. Some students like to do more manual things like flashcards or models. It really depends on how you learn the best. And again, if something isn't working, consider trying a different method. We have students who keep doing the same thing over and over again sometimes, and they're frustrated because it doesn't seem to help. But maybe it's just the way that you're studying or the way that you're going through that material. So just think about doing things in a different way. Think about how you learn best, how you like learning best, and maybe that will help. And then to improve your outcomes, it's really important to identify your strengths and your weaknesses. And you should know what those are, and hopefully you know what that is. But think about some of those things. Think about setting realistic goals. And, you know, for example, if you failed exam 1, you're probably not going to get an A on exam 2. You might, but maybe it's just working hard and pacing yourself and coming up with a different study plan for exam 2. That's going to be a better thing. So formulate a plan. Think about how you want to attack that exam. Think about your study time. Think about your time management. Think about the way you read and write and take notes. And then check your progress. Maybe your plan isn't going as well as you thought it was going to, and that's okay. But be able to decide how you might change that. And then for time management, just the basics, right? So how many days of the week do you study? How long should you be studying outside of class? We always say in MCB that for every hour of class time, you should be studying 3 hours. That's a lot. Is that realistic? I don't know, maybe it depends on the week, right? Maybe it depends on what else you're doing. But these courses demand a lot of time. Absolutely, they do. Do you schedule your study time? There's all different ways you can do that with a planner or your electronic calendar system, whatever you think is helpful to you. And then do you actually study when you have yourself scheduled? So a lot of the advisors are going to talk about study skills and time management, and you might have a grid of when you're going to do all of your studying, but is that actually when you study? So just think about what's realistic for you and how you're spending your time. And then this is the study, the maintenance studying form from the MCB advising website. They have lots of different resources there for study skills and time management, and this just takes some of the questions from it. The what, when, why, where, how much. So for what? Keeping a schedule with your dates clearly organized. And this should include, other than just weekly things, when your exams are, when your quizzes are, when you have big projects due, big papers, anything that's that you need to include on your schedule. When? Being consistent. Think about using your time before and after class. So if you have a 2-hour break, it might be tempting to go home and take a nap, but you could get a whole hour done of reviewing your notes if you think about that. And use the time throughout the day. Set a routine. Something that's predictable is going to be a lot easier to keep track of than doing something just randomly throughout the semester. Think about where you study, the location. Think about all the other distractions that you have. So either in-person distractions, online distractions. Think about those things. And then how much. Think about realistically how much time you need to do all of your work. There's lots of other things going on. You have all of your classes, you have activities that you're doing. A lot of you guys have jobs, research, all kinds of things. So it's tough, but that's why having a nice grid, a scheduled plan is going to really help with these types of things. And you really do need to set your own personal goals for this. So you have to decide what you're willing to do and how you're willing to budget your time. And that means that you're going to have to set priorities. And so depending on the semester and what you're working on, those things might change, but you really do need to hold yourself accountable for that. And part of having a good plan and a good schedule is that if things come up and you have unexpected things happen, you can plan for how to deal with that. So things like getting sick. There's a lot of illness going on right now. If you're going to be, out sick for a few days, how can you adjust your study time? And taking control of your time. Again, think of all the time in your week, all of the hours, all the time that you waste doing random things where you might be able to squeeze in some study time. And then making the commitment to follow through. It's nice to have the schedule, but if you're not going to follow the schedule, then that doesn't really help, right? So carry out your scheduled plan. And if you aren't able to do that, think of how you can adjust and edit and come up with something that might be a little bit more realistic for you. All right, so go back to thinking about what you can do to be successful in biology. Hopefully you can think of some additional things now that you might take away with you today. And then I leave you with this image of learning to ride a bike. So how do you learn to ride a bike? You have to practice it, right? You can't just read about bike riding in a book. It's something that you have to do. And much like this, learning how to be a student, how to be a science student and a biology student is really a skill. And so it takes practice. What you did in MCB 150 might not work just as well in 250 or in 252 or in 354. And so you need to kind of develop these skills and figure out what works for you. You can try a lot of different things, right? So you might fall off the bike, you might have a bad semester, a bad exam. It's just a matter of getting back on there and just continuing to practice and continuing to try. And so it's a process, it's not easy, but hopefully when you put all these different pieces together in different ways, you can come up with something that works for you. And so today we talked about critical thinking, we talked about reading and note-taking, we talked about approaching exams in science, learning styles, and a review of time management. And then just as a last thing, a few quotes from current and former students. And a lot of these are things that we talked about today. So things like office hours, going over the PowerPoints, talking to your professors, becoming involved in different community activities, managing time. Think about wasted time in between classes and when you get things done. Sitting in the front of the room, talking to your classmates, talking to your instructors. These are all things that should help you. And then most of the information that we talked about today you can find in some form on the MCB Advising website, and so make sure that you look at that. There's also the MCB Advising Facebook and Twitter and blog and everything else, and so make sure that you, if you don't already, follow them. Get a lot of information, and Roadmap, our weekly email newsletter as well for any of announcements and upcoming events and any other opportunities that we have upcoming at MCB. All right, any questions or comments or anything that anyone wants to talk about in addition to what we covered or related to what we covered today?